Hey YouTube, it's me, Luna Kepio. How's it going? Um, so this will be the very first tutorial I'll be making. It's a crash test. We will see how it goes. Ever since I was a kid, I have always dreamed of making my own video games. Programming, like I've been born in Nintendo's world with Mario Kart, Diddy Kong Racing, and stuff like that. Ever since then, I've always wanted to make my own game. But I never took the time to learn game development with Unity or Unreal Engine. But I'm a web developer, so I learned 3GS. And today, what we are going to make is to make our own Mario Kart controller, only a kart controller for now. I think like the way it will go is that we'll start by making this tutorial, and then we'll upgrade it every time with like animation, track, Blender and stuff, all the stuff that is needed to make a real 3D project. So today we are going to make this card controller with React 3 Fiber and 3GS, and it works with a controller. So you can see we can drift, we can steer, accelerate, and decelerate. Pretty cool, right? To start the project, you can get my R3F vid starter. It's totally inspired by Wawa Sensei, but instead of npm, it runs instead of yarn, it runs with npm. And for reasons, I prefer to use npm for my project. Copy the URL in your clipboard, paste it in your terminal with git clone. Go into the project, run npm install code dot to code inside the repository, and in the terminal still run npm run dev. Press Ctrl click on the link to open the project in your web browser. So to make the project, we will need two things. We will need the environment, the physics, and a hook that I actually made, which is called use gamepad. So we'll start by getting the hook I make there, go into the usegamepad.jsx, copy, go into your repository, add a component, call it usegamepad.jsx. So make sure it runs great, then delete all the thing, go into Sketchfab, fetch for a kart, and take any of the one you like. Make a models folder inside both your public and your components. Once we got the kart we want, place it inside the models folder we made it in public. Rename it however you like. I will just remove the space, that one, because I already did one, so this is why they added a one. In the terminal, go into public models and run npx gltf gsx racing -- transform -- shadows to add the shadows. This will be used if we add the light into our scenes. So you can see it will generate us a card.jsx. The model has a ground that comes with it, so I will remove it right now, and we will name our model kart, and we will make it, and we will place it inside our components models folder, which contain, this is the way I organize myself, but it contains all the model I use for my video game. So yeah, okay, alright. Inside there, make sure to add the correct repository fetching. So public slash models dot slash public slash models. I'm not the fastest, as you can see. Experience. Inside our components, we'll first make a kart controller.jsx file. Kart controller. Fat arrow. Return. We'll make it inside the group and kart. Inside our experience component, we will run the kart controller. We'll see everything runs well because it's well loaded and placed inside our experience. So what we'll do inside the kart is that we add a perspective camera from React Dry, make default, and we will place it however we'd like regarding our kart model. So basically x0, y2, 8 on the z-axis. What happens is that I have a third-person camera set up just like that. I don't have to make calculations or everything to place the camera, because usually you would use trigonometry to do something like that. Here, we won't do that. So, for later, we'll add a kart ref, a player ref to this component, to this group, player. It will crash because we need to declare our ref first, but we will not do that yet. Group ref égale kart, because this is the kart. So what we will do is we will declare our ref. So const kart égale use ref. Const player égale use ref. Alright, so for now it still works. What we will do is we will add, I have a doubt, yes. Add. We'll add a rigid body from React Tree API. We'll say colliders égale false is equal to false. CCDD. This is continuous collision detection. So it's Anderson Mancini that taught me that. It's actually very useful because it will always detect the collision, which is what we want for our player. Position is equal to 0.0.20. Rotation is equal to 0.0.0. And inside we'll place a ball collider from React Tree API, and we'll just set an args of 0.5. It won't work because I believe the args must be inside an array. Yeah, I was right. So that's 5. And then you can't see it, but there is a ball collider here. Oh, actually, no, we won't see it because it fell down because there is no ground. We'll make a ground component. Return a rigid body. Type is equal to fixed. Inside we will place a mesh, which we will rotate already on the x-axis, because otherwise we are going to place a plane geometry, and if we don't place it on the x-axis, it will be like that, so it will keep falling as well. Rotation is equal to oh, geometry is equal to mil 1000, and then we will place a mesh standard material, opacity is equal to 0, transparent. We shouldn't see it, but there should be a plane. Add our ground. Add our ground. So as you can see, there is our ground there. We can see a yellow line, and our ball is here. So before diving into the project, we will need to define our parameters for the scene. So we need to set, we need a set state for the current speed and the current speed. I will explain this later. Why state instead of use ref, just like almost everything. So we need to explain max speed, an acceleration factor, a deceleration factor, a max steering speed. We need to set state also for the max steering speed. We'll explain later. A steering angle, a drift direction, a drift force, a drift left, drift right, and we need to check if RB, which is the shoulder button on the right controller, is held. Oh, I'm so uneasy doing this. It's horrible. The idea of how the physics work is that instead of having a vehicle with 4 wheels, where you would have to check the dampers, check the rotation of the wheels, make them work together, join them, we use a sphere collider. It's a cube, but it will say it's a sphere because I tell you it's a sphere, so you believe it's a sphere. You must. It's a mind game. And the idea is that we will rotate the sphere to match the acceleration, and we will rotate the sphere based on the kart's rotation. So based on the kart's rotation, we will get the sphere's forward direction, and the sphere will only move forward. To first do, what you need to know as well is that the entirety of the kart controller logic will be placed in a use frame function. So what a use frame do is that it's a loop that is called every frame. So every instruction we set inside of the loop will be called every frame the computer render. And as my computer runs at 144 frames per second, it will render 144 frames 144 times a second. First thing we're going to do is to check if every of our ref which is inside our return statement is up and running, because if any of those isn't there, the use frame won't work and the project will break, which is not something we want. We need to get the kart rotation. We need the forward direction of the kart because what will happen is that we will apply force on the sphere collider based on the kart rotation. Before going any further, we're going to use my use gamepad hook, so you can see how it's called. Inside an object we store the button A, the joystick, and the RB button. We could also use any of the buttons we like, but this is the only one I need. And then we'll move to the physics calculation. So how it works. So we apply an impulse based on the kart's forward direction, as explained earlier. We will match this impulse with the current speed, which we will increase later, by the delta. So this is the delay between each frames. So this is used so we have a constant behavior whether the reverse rate, minus the body current linear velocity to get the deceleration. Otherwise, we get a constant impulse. Minus by a damping. Forgot to add that. Pressed, if button A is pressed, we will increase the current speed to the maximum possible, which is max speed. Else, we will just reduce the max speed by our deceleration factor. Oh yes. Oh, things break. As you can see, our ball rotates. Here what we are going to do is that we will copy the position of the ball and set it to the position of the kart. So our kart will act like the ball, but it won't rotate, because if we copy the ball's rotation and position, what will happen is that our kart will rotate over and over and over and over again, and as we placed the camera inside the kart, the camera will also rotate over and over and over and over again, which is not something we want. We only want the position of the sphere. So what this does is that we will, as well of the current speed, we will increase the current max steering speed, because like as you can guess, if the vehicle is stationary, the max steering speed will be 0, because like if you're on place, you can't rotate left and right. So we define our steering angle to joystick to the first array of a joystick, which is the x-axis, by the current max steering speed. So it will be increased or minus equal to 0 if necessary, and we will rotate the kart based on this steering angle. As you can see, it works just great. But that's my bad, because it's not the kart we should rotate, but the entire player is based, yeah, player. And then we have our kart controller, and it works just fine. And that's it. You made a kart controller that's playable with a real gamepad. Great, right? But we won't stop there, because we want to drift. You want to drift, right? We're going to drift. We will first press RB, and RB will be used to set the RB is held to true, and we'll then set the drift force to 0.4. If we don't press RB, if RB is not pressed, everything is reset to false. This is how we can do the drift release if we want to add then implement a boosting system. Then what we do is that we need to commit to one drift direction. So it will be either 1 or -1. So we'll check if RB is held, if joystick is on the on the right side, sorry, because the joystick goes from -1 on the left to right 1, and we'll set the drift direction to 1 and set the drift right isn't true. We need to also say that we shouldn't be drifting left, because as it's a drift frame, it's repeating the loops again and again. So like if I didn't do that, what would happen is that we would switch from drift right, drift left every time we switch direction, and this is not something we want. We want to drift. So then same thing with the drift left this time. So we check if the joystick is on the left side, and then like if we're on drifting, we set the steering angle just like we did before, and if not, we will decrease it by 1. So it will commit the drifting, and if on the right, we will increase it by 1. What's happening is that, as you can see, we are drifting because like we can't go straight anymore, which is exactly what we want. But we can't see it yet, right? So what we'll do is we will call mass utils from tree. And what we are going to do in the next part is just give you the basics for animation, because you will do it yourself. This tutorial is already way too long and way too bad to go any further. I'm just going to give you the basics of how to animate based on the drift, so it looks like a drift, because as you can see, it can go sideways, but the camera is still behind, so we don't really see the drift, which is not something we really want. And then what we do is that we'll use the lerp, which is a linear interpolation of the rotation of the kart, and we will increase it or decrease it based on the steering angle, so it will look more natural. This is a smooth step, so it defines how much we will increase the rotation every frame of the kart rotation. What's happened is that we have something a bit animated. It looks more natural. And that's it. We have our kart controller. Alright guys, congratulations, you have made it up to here! Congratulations, so you have made your own kart controller. I'm so sorry if it's badly explained. If somebody is willing to explain the things in a better English than mine, feel free to do it in the commentary section. All the links will be down below in the description. And I think that's it. I said everything needed. See you!